Hello and greetings to everyone. Today we are going to treat the approximation to a specified number of decimal places. Approximation to a specified number of decimal places. When we talk of decimal places, we are simply referring to the digits that come after the decimal point in a decimal number. You can watch our videos on decimals. You will learn so much on decimal places. Let's take this down. To approximate to a specified number of decimal places, bracket DP. This is how we abbreviate decimal places in a given number, we start counting the required number of decimal places immediately after the decimal point, and we round off. Means after counting the required number of decimal places, we round off at the last specified decimal place. That means if you are to approximate a given number to 3 decimal places, after counting the 3 decimal places, we round off. When we talk of round off, that means we either round down or we round up. If we take this down, note we count zeros within a decimal number as decimal places. The zeros fall immediately after the decimal point, then you count them as decimal places. Let's take this example. For question 1, it goes write the number zero point 0.3124 to a 2dp. That means 2 decimal places, p 3dp. There is 3 decimal places for c 4dp. We take solution. we have the number 0.03124. Counting the number of decimal places in this number, we have 1, 2, 3, 4, 5. For E, we have to express this number to 2 decimal places. We have 0.03124. To 2 decimal places, we are simply going to count the 2 decimal places. We have 1, 2. We have to round off between 3 and 1. 1 is less than 5. It is rounded down to 0. And this will be approximately 0.03 to 2 decimal places. For B, we have to express the number 0.03124 to 3 decimal places. We are going to start by counting the 3 decimal places. 1, 2, 3. We round off. 2 is less than 5. It is rounded down to 0. And this will be approximately 0.031. 3 decimal places. For C, 0.03124 to 4 decimal places is approximately, we are going to count the 4 decimal places. 1, 2, 3, 4. We round off. 4 is less than 5. It is rounded down to 0. And this will give us 0.0312 to 4 decimal places. We move now to example 2, which says write the number 8.8567 to question A, 1 decimal place. Question B, 2 decimal places. Question C, 3 decimal places. We have the number 8.8567. Take question A, we have to express it to 1 decimal place. 8.8567 to 1 decimal place. We are going to count the first decimal place. It is after the decimal point 1. Then we have to round off between the first decimal place and the second decimal place. 5 is greater than or equal to 5. It is rounded up to 1. We add the 1 to 8. This 8 tenths gives us 9. This will be approximately 8.9 to 1 decimal place. We go to B, 8.8567 to 2 decimal places. We're going to count the 2 decimal places. 1, 2. We round off between the digits 5 and 6. 6 is greater than or equal to 5. It is rounded up to 1. We add the 1 to this 5. Gives us 6. This will be approximately 8.86 to 2 decimal places. We move now to C. We have to express that number 8.8567 to 3 decimal places. Count the 3 decimal places. 1, 2, 3. Round off between the digits 6 and 7. 7 is greater than or equal to 5. It is rounded up to 1. We are going to add the 1 to this 6, which gives us 7. And this will be approximately 8.857 to 3 decimal places. Let's move now to B, which is approximating to a specified number of significant figures. Approximating to a specified number of significant figures bracket SF. SF stands for significant figures. Let's take this down. We can approximate by specifying the number of significant figures that must be kept in the approximated number. First, to approximate a number to a number of significant figures SF, we start counting from the first non-zero digit in the number. Starting from the left to the right, up to the required number of significant figures, and we round off. We round off to eliminate the other digits which are not required. We take this down, note, now underline the first non-zero digit. It's very important. 0 or zeros after the first non-zero digit or 0 or zeros between non-zero digits are counted as significant figures. But if a number starts with 0.000, the zeros at the beginning of that number, they are not significant figures. But if the zeros are found between non-zero digits or after a non-zero digit, then the zeros are counted as significant figures. Let's look at some examples on this. Take examples. Question 1 goes express the number 8459 to A, one significant figure, B, three significant figures, C, four significant figures. Take solution. First, we start by writing down the given number 8459. For A, we have to express this number to one significant figure. Remember, we start counting the significant figures from the first non-zero digit of the number, starting from the left hand side. This is the first significant figure. 8, 4 is the second, 5 is the third, and 9 is the fourth. Approximating this number to one significant figure simply means we have to round off between the first and the second significant figures. We draw a vertical line here, and this will be approximately 4 is less than 5. It is rounded down to 0. This will give us, write the first significant figure, which is 8. Then we replace all the other digits with zeros. And this will give us 8,000 to one significant figure. For B, we have to approximate this to three significant figures. This is the first significant figure, the second, third. We round off. 9 is greater than or equal to 5. It is rounded up to 1. We add the 1 to this 5 tens. This will be approximately 8,460. So 3 significant figures. For C, we have to express this number to 4 significant figures. It is the first, second, third, fourth. So to 4 significant figures, the answer is simply the same. It is equal to 8,459. In this case, I'll make use of an equality sign because they are the same. We move now to example 2. For example 2, it says express the number 0.0050467 to A. We have two significant figures. B, we have three significant figures. And lastly for C, we have 4 significant figures. Take down solution. The given number we have for 0.0050467. For A, we have to express this number to two significant figures. Remember, the first significant figure of a given number is always the first non-zero digit of that number. These 2 zeros are not significant figures. These 3 zeros. 5 is the first significant figure of this number, followed by this 0. This is a significant figure. This is the third, fourth, and fifth. Expressing this number to 2 significant figures simply means we have to round off between the second and the third significant figures. 4 is less than 5. It is rounded down to 0. This will be approximately 0.0050. So 2 significant figures. We go to B. We get to express the given number to 3 significant figures. This is the first, second, third. We get to round off. 6 is greater than or equal to 5. It is rounded up to 1. If we add the 1 to this 4, which gives us 5. This will be approximately 0.00505. We go to C. We have to express the number to 4 significant figures. We count 1, 2, 3, 4. We round off. 7 is greater than or equal to 5. It is rounded up to 1. We add the 1 to 6, which gives us 7. This will be approximately 0.0050047. So 4 significant figures. This is how we perform approximations to a specified number of decimal places or a specified number of significant figures. If in case you have any questions, feel free to leave your questions at the comment section. Please, you like the video, share, and subscribe to this channel. Stay tuned to our next lesson, which is on estimation. Thank you very much for watching.